Hello, my name is David Hall, and I am from the IoT M2M Council, and it is my pleasure to welcome you all to the IIoT Summit presented by the IMC. Today's agenda will start off with a keynote about a new security initiative that the IMC is starting, followed by our panel discussion on AI meets IIoT. What are the new industrial applications? Before we begin, we wanted to cover a few housekeeping items. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or your headset are turned on and that the volume is up so that you can hear the presenters. An on-demand version of the webcast will be available later today and can be accessed using the same audience link that was sent to you earlier. If you have any questions during the webcast, you can submit them through the Q&A box on the right side of the screen. The presenters may answer questions at the end of each session, but please feel free to ask questions at any time during the presentation. Any unanswered questions may be responded to offline, and so please make sure to ask if you have any. Also, please check out our handout section on the right side of your screen that our presenters will provide some handouts for you throughout our webcast. Now with that, I'd like to introduce our first speaker, Keith Kreischer, the Executive Director of the IoT M2M Council, who will discuss a comprehensive, practical IoT security program. So Keith, welcome, and please take us away. Keith, I believe you are muted still.
Forgive me. Sorry about that. I am Keith Kreischer, Executive Director of the IMC. And for those who don't know us, the IMC is the largest trade association dedicated to the global IoT sector with 28,000 qualified IoT buyers as rank and file members. We call them adopter members. They cover 27 different vertical markets of application, and they come to us from virtually every continent. Roughly 30% are in North America, and the rest spread out around the globe. I'm here to introduce our panel discussion today on AI and IoT, converging in industrial applications. That'll be moderated by my good friend, Renil Paramel of Strategy of Things Group. But first, I'd like to address this audience about an issue that, along with AI, is one of the burning issues of our time, I think, and that is IoT security. The security of data and connections used and generated by remote devices. I'll speak for about 7 minutes. The panel will follow. That's about 45 minutes or so. And I guess the first question is, why do I want to talk about IoT security? According to one analyst group, the number of IoT cyber attacks topped 100 million in 2023, up from around 30 million in 2018. Regulators, like most of the rest of us, have woken up and are passing regulation on IoT security at an increasing rate. This is by no means a comprehensive list that you're looking at. It's taken place in the US and Europe in the last 90 days, and not even comprehensive in those regions at that. If you're really interested in keeping up with regulations, the IMC does have a public policy channel. You can access that through our website, and it actually indexes global regulations. So for those interested, I would suggest you take a look at that. The IMC Board of Governors met last month in Nuremberg, Germany, to discuss these developments. Important to note that the IMC board consists of more than 30 of the most influential IoT technology companies around the world. It's a pretty eclectic group: telcos, MVNOs, satellite service providers, hardware makers, software providers. And I think it's fair to say that these are the companies that are actually doing IoT. It was their considered opinion that a lot of the current efforts in regulations, certifications, and standards typically lack comprehensiveness and practicality. They often focus on particular vertical markets or technology subsets and tend to offer process-oriented requirements that can lack hands-on advice. As a group, the decision was made to pursue a set of comprehensive practical guidelines that would be of use to IoT users, but also technology providers, regulators, and more. The issues surrounding IoT security, we felt, were simply too important for our group not to be involved, and hopefully to lend some organization to what is a very fragmented landscape for IoT regulation. The IMC sees itself as uniquely qualified to take this effort on, both on account of the eclectic practical knowledge of its board companies and its ability, and more so for its ability to promote best practices to its rank and file membership of 28,000 qualified IoT buyers. Frankly, we don't know what these guidelines are going to look like at the end of the day, but we have agreed on a couple of overriding principles that they should follow. They should be comprehensive, and crucially, they should offer shared learnings between different vertical markets and different technology layers. They should be practical, offering hands-on advice from people who have been there and done it. And finally, they should be referenced, pointing to work that's come before, perhaps in some kind of index form. You see here our reference to NIST, the IoT Security Foundation, Cyber Trustmark, and the CRA and the EU. We certainly want to point to those activities. What we hope to come up with is a practical living document. We assume that regular updates will be required for that, and that these will in turn require us to get together on a regular basis. The project will be overseen by the IMC Board of Governors, and in particular, our new vice chair, who is Ellen Boehm of Keyfactor. We consider Ellen to be an obvious choice for this. Keyfactor is a pioneer in public key infrastructure for device security and one of the most highly regarded firms in this entire area. We've broken our efforts up among 3 working groups. We believe this is very important. Each group will represent a different layer of the IoT stack. We've got Harold Remmert, CTO at Digi, heading our device group. Z Hossein, founder at Eris, heading our networks group. And Fred Jens, a principal at Tardibit and formerly at Telit and ILS, leading our cloud apps group. Each one of these guys has decades of experience implementing IoT technology in the field, from the most cutting edge deployments to the largest in scale. This slide will just give you an idea of what the 3 groups will be tackling, and only at the very highest overview level. We think having these 3 groups dedicated to the task and most importantly, coordinating with each other is absolutely crucial. In short, and to oversimplify, what good is having a secure device if your network and your cloud service are permeable? This next slide will just sort of outline the overall timeline for the project. We think it's fair to say that this is subject to change, but we are in a hurry. We believe these guidelines could have an impact on any number of regulatory efforts moving forward, and we're asking interested parties to join us in this effort. Specifically, and as a first step, we're asking parties interested in IoT security to join us in open discussions this month. Each of these groups will hold 2 forums. Frankly, again, we're not sure what we're going to get, but we think it's important that these meetings be open, completely, as it were. And I would ask everyone listening to please note the dates on the slide. The link below is available on the PDF download. And of course, more information is available on the IMC website. Perhaps important to note, these meetings will be in a slightly different format. So if you do register, you'll receive an invitation from us that will allow you to participate. It's not a webinar format. Everyone participates equally on these discussions. And then finally, in summary, I'm just going to read this slide aloud. The IMC's objective is to create a set of practical guidelines or best practices for deploying IoT technology with appropriate levels of security and privacy that can be applied across a broad range of technologies and market applications. In doing so, we hope to lend a framework to efforts to promote IoT security by various industry groups that have come before, while referencing and leveraging work already done. This is exactly in keeping with the IMC's mission of promoting the deployment of IoT technology for the public good. Thanks so much for your time. And again, any and all interested in joining us, please use the link on this PDF download or come to the IFC website. I would also encourage folks to reach out to me directly. Anyone who's interested, I'm happy to talk on this subject. And those are my contact coordinates. And with that, I'll just leave this slide up. With that, I will introduce my good friend and colleague, who is Renil Paramel, principal at the Strategy of Things Group. Renil, good morning.
Good morning, Keith. How are you?
Good. It's awfully early out there on the West Coast.
Yes, it is. Thank you, Keith. Good morning, everyone. Welcome to IMC's AI Meets Industrial IoT panel discussion. My name is Renil Paramel. I'm the CEO and co-founder of a company called Strategy of Things. I will be moderating today's panel discussion with two fantastic and experienced panelists. Today's session will focus on how AI is impacting industrial IoT. We have all been hearing a lot about AI, especially over the last 12 months, with generative AI catching the attention of consumers and enterprise around us. We'll discuss some of the AI opportunities, trends, and challenges in industrial IoT at today's panel discussion. Each of our panelists will have a few minutes to give a little background about themselves and then talk about their perspective as well as their company's perspective on how IoT and AI and all are kind of coming together in the industrial IoT world. Before I introduce our first panelist, let me share a little bit background about myself and Strategy of Things. Prior to starting Strategy of Things, I was a VP at Gartner with their consulting practice. And prior to that, I spent a number of years with Accenture and Deloitte, providing advisory service across a variety of industries. Strategy of Things is a firm that offers consulting and professional services to clients that are looking for smart technologies around cities, communities, buildings, and spaces. We provide planning, assessment, and advisory services in IoT and AI. I'm also a member of the CompTIA AI Council. With that, I would love to introduce our first panelist, Scott Barnes, who is the Vice President of Sales for Fleet for Core Wireless. Scott, over to you.
Good morning, everybody. Real quick about me, I've been in what we now call the IoT business for about 25 years. Kind of worked over all parts of what we now call the IoT stack, from hardware devices, connectivity, MVNO, both MVNO and carrier, hardware, but primarily around the kind of the SaaS front end piece. For the people here that don't know Core, we just had our 20th anniversary back in 2023. Company started off as primarily an MVNO, providing connectivity as a service, exclusively for then M2M and now IoT applications. But since then, we've really built out a whole litany of services and solutions to help bring IoT solutions to market. So we're starting off at the build piece. We can design and build hardware. We can then help customers deploy either by scripting, configuration, logistics services, and then help kind of future-proof and manage those devices once they hit the field. So once they're connected, keeping firmware up to date, keeping software up to date, and really managing that life cycle so that our customers, who are the solution providers, to get the most bang for their buck and keep those devices in the field as long as possible. And kind of where we see AI right now in industrial IoT is we've kind of gone through what we call the static IoT base. Those are kind of rule-based algorithms. I think most people here have gotten through and kind of dealt with early chatbots, where you had a very set amount of responses. We're now sort of moving through dynamic AI. So there is some machine learning, very large data sets that those chatbots can kind of learn. It's, again, primarily generative AI. And we see it now moving into predictive AI. Those predictive elements, much more advanced learning techniques, where the AI itself can actually look for trends, look for behavior, going back through historical patterns, and then make a very decision-based insight recommendation on what to do next. And Renil, I'll hand it over back to you.
Thank you, Scott, for giving us a quick overview of your background as well as core and how you're looking at AI from a company perspective. Our second panelist is Jim Hassman, who's the President and Chief Revenue Officer of Blues. Jim, over to you.
Good morning, everybody, and thank you again for the opportunity to participate in this webinar. Just a little bit about me. I'm the President and Chief Revenue Officer of Blues and a partner of the guy that you see on the screen here, Ray Ozzie. I'll talk about Ray in just a second. Prior to joining Blues in 2022, I spent 12 years in the enterprise AI space. And in fact, that market category didn't even exist when I started the last venture that I was at, which a company called C3 AI. I was early at that company when it started, was in products for most of the time, and then eventually moved into the commercial side of the business towards the tail end of it as we took the company public. But have a lot of product expertise in actually building enterprise AI applications, probably more so than IoT. Scott could probably dance circles around me on the IoT discussion, but AI is something that is near and dear to my heart, and I've seen successes with it. I've seen failures with it, and I look forward to the conversation today. Just a little bit about Blues. We are still considered, I would say, a startup. Hopefully we'll always have that mindset, because I think you operate very differently when you consider yourself a startup than when you consider yourself a behemoth. This company is a hardware-led SaaS company. We sell hardware and a companion software product in the cloud. Those two products are called Notecard and NoteHubs. We're very focused on one problem, and that is solving the connectivity challenge of connecting physical devices, physical assets, or physical products to the cloud. Some have described us as connecting the unconnected. Someone else came up with this one, which may be my favorite. We're the world's simplest IoT data pump. And if you think about the challenge of AI, the challenge is actually in data more so than the types of AI you apply. It is actually in the data sets itself. So happy to be a data generator. Company was founded by tech legend Ray Ozzie. Some of you may have heard of Ray. If you haven't, he's a serial hyperscaler. He started 7 companies. He was the creator of Lotus Notes, which I think is coming up on its 40th anniversary, believe it or not, this December. He was one of 7 of the Windows pioneers. There's only 7 people on the earth that have that designation. And he took over for Bill Gates in 2006 as chief software architect of Microsoft. And some of the projects that he led there were Azure, Live, Xbox, and Office 365. And that was prior to starting Blues. He's on boards and does a whole bunch of stuff, but he is the main developer, product developer at Blues. He's very hands-on. Just a little bit about what Blues does. Okay, over on the left, there are devices or assets or products, if you want to think of it that way. What Blues solves is the middle problem, the connectivity problem. We basically create these hardware modules. Some people call them a system on a module. I call it a super system on a module, or a super SOM. They come in 4 flavors: cellular, Wi-Fi, LoRa, and satellite. You can swap these things in and out of a product without changing your API to the cloud. That is very unique to us. And we allow customers to use their own host, to use their own sensors, and to route the data to any preferred cloud application that they want. So we solve the middle problem of connecting products to the cloud. We're used for remote monitoring, tracking, and control across, I think, all industries now. We're in a bunch of different projects and use cases. Environmental happens to be the largest one at the moment, but we're in energy, batteries, clean tech, ag tech, electrical vehicle charging, healthcare products, oil and gas, and even down to the bottom right, we're even in porta potties. Connected porta potties are actually becoming a thing. But yeah, Blues is used for lots of different applications. And I think as it relates to this topic today, I really want to focus on the data sets being generated for the classes of AI that someone might use on top of IIoT. And just one simple plug, if any of you guys are interested in trying Blues out, you don't have to be a developer to do this. You can actually buy a dev kit right off of shop.blues.com. Shows up, I think, in about 2 days to your address. And in about 30 minutes through the online tutorial, you'll have a working IoT device pumping data to the cloud. So give it a shot if you're interested. Back to you, Renil.
Thank you, Jim. We heard a little bit from both of our panelists about their background, a little bit perspective about their company and products. Let's get a little bit more into what AI means in the world of IIoT. So from my perspective, I've been looking at IIoT for a while, and some key things that I'm kind of is that you have machine learning, deep learning that is kind of revolutionizing operations by enabling predictive maintenance, anomaly detection, process optimization going on. Then you have edge AI that you're talking about for real-time data. Then you hear about reinforcement learning, you hear about NLP, you hear about explainable AI. There's so many terms going on. How do we help our viewers, listeners kind of break this down from the beginning? What are the opportunities that's there in IoT for AI at the level? And what are some of the trends going in terms of picking up what generative AI is offering and other models are offering? Maybe Jim, you can start with that.
Yeah, I think maybe before talking about the IoT context, maybe just setting a backdrop about what have been the predominant approaches to AI in industrial contexts. A lot of people are familiar with this from a consumer standpoint as they interact with various things, that they may have in their homes or on their phones. But in industrial contexts, this is really about extracting data from physical devices, combining that with other environmental data sets. So it could be data from other machines, it could be operational impacts, it could be market information, to develop basically trends and stories to train algorithms. And I think that is probably the simplest way to describe what this is. Now, machine learning is a class of AI. Deep learning is a class, computer vision is a class, and obviously Gen AI as it relates to large language models or large action models are a class, and those are definitely exploding on the scene right now. But for most people, I think as a starting point, the basics of approaching predictive problems, what might happen, is really the question that you're trying to answer, is typically done with machine learning. And the reason that people start there is they assemble the data sets, they create the training set and the test set, and they're able to basically massage the variables and the inputs that go into training a machine learning classifier to create some output. They'll see the precision of the output, they'll make mistakes, they'll retry it, they'll see the recall of the output, and they'll make business decisions based on those factors. Deep learning is a little bit different because you basically feed the algorithm data and it makes all those decisions for you in a black box. And so most industrial applications will start off with machine learning, I feel, as their base starting point. There are a lot of tools now available that didn't exist 12 years ago when I started doing this, that allow operators to do this, where you don't need hands-on data scientists to develop certain things. There's a lot of libraries available now that didn't exist 12 years ago, and it just keeps getting better and better and easier to use. And that really is hopefully the continual trend where it becomes a commodity for people, and even so much so that commoditized to the point where you're getting recommendations on what class of AI to use for a specific problem based on the data you have. So to me, that's kind of the starting point and the backdrop of this, regardless of an IoT device or not an IoT device, is ML is kind of for me, that is kind of the foundation. But there are other classes, depending on your problem, that may be better. And it's a journey, it's a learning experience, and it's ripe with failures. It's ripe with learning that your data are garbage. So I think that's kind of the place that most people start. I think at this point, most people are probably familiar enough with it, or at least tried it within their businesses to know where they've succeeded and maybe where they haven't.
Fantastic. Maybe Scott, maybe you can give us some light on, from a course perspective, what are you seeing some of your clients doing in terms of low-hanging fruit use cases? Says, hey, here's some more sophisticated use cases that's kicking in that that you're seeing as trends picking up in the space. You maybe on Scott.
There we go. There are a couple that we see that keep coming up, and I think the first thing that we see with customers is right now there's a lot of buzz around AI, and they don't really know what they want the AI to do. So trying to help them, direct them into really what is the business case, what is the problem you're trying to solve with AI, versus just trying to kind of hand jam some AI solution into your stack. But the ones that keep coming up, the biggest one for me and kind of the fleet and the industrial side is around predictive maintenance. We see that a lot popping up, where customers want to use AI to kind of analyze data from a wide variety of sensors, predominantly at the edge, and try to figure out what to do. When does a device or when does an asset need to be maintained? Looking at kind of minimizing downtime and improving overall usage and efficiency of that asset. There is some demand forecasting, kind of tying AI into both ERP and CRM systems to really kind of optimize inventory, optimize production planning, and make customer engagement much tighter around that kind of buying piece. And kind of moving, tying different parts of the business together, so kind of supply chain optimization. So as pieces of things are coming in, let's say on a truck, from truck to factory to build, finished good, then back on a truck being sent out to customer. So getting lots of visibility across that supply chain to be sure their customers are properly taken care of, and also maintaining cost and improving delivery times in that scenario. Those are kind of the big ones we see. Some kind of ancillary ones. Customer service, I think most people are kind of used to the chatbots now. There's a lot of questions around that. What's that actually worth to the business? And some energy management. Energy management's always a big one. But as energy prices fluctuate, it's harder to get a firm ROI on that piece. So those are the most common that we see today.
Fantastic. So when folks are looking at industrial IoT opportunities or industrial opportunities to kind of use AI, what should their approach be? Does it make sense to kind of look at all these wonderful different use cases, or does it make sense to kind of organize around, hey, here's some low-hanging fruits, like maybe just condition monitoring of machines, or maybe and then as you start getting yourself adjusted, equipped with the new way of thinking and technologies, you kind of start adding more use cases into your portfolio. Is that kind of the right approach, or what are you seeing in terms of what people are doing as low-hanging fruit versus more advanced stuff? And what would you recommend our listeners to kind of use as a strategy as they start trying to figure out how to incorporate AI in organizations and into their organizations? Jim?
Yeah, I think if I was to summarize the question, where does one start? And how do you make a decision on what to do first, second, third? I really think the first thing you got to look at, there are two things that, and both of them are weighted equally. Okay, the first one is potential economic benefit, or other benefits. It might be a safety benefit, but most of the time, larger corporations will focus on projects where they're actually going to improve their operations, they're going to improve their financials, they're going to have a product that's easier to support, better to maintain, whatever, competitive in the market. One of the most frustrating things for me in the last company that I was at in working with customers on this problem was they would give us a list of like 30 use cases they think were ripe for AI. And when you read through the descriptions of these things, a lot of them were, to Scott's point, predictive maintenance based. I was always looking for, okay, so what? So what if you solve this problem? What is the impact to the business? Yeah, it's a cool idea and somebody's maybe pet project, but there's only so many hours in a day to focus on this stuff. And so I really think you have to prioritize AI choices based on what benefit you are going to get out of it. And it needs to be calculated. I'll give you an example. We worked on one that was this was early on in the project, but it was in the energy space. The use case was if we were to apply machine learning to a electrical meter, smart meter data set of like 30 million meters in Europe, could we predict at what meter point theft was occurring? Okay, the value of solving that problem was significant. If we could detect, let's say, 20% of the theft, and you could actually go out and affect 20% of that, the economic benefit to that company was huge. And so that was a good classification of a problem. A bad classification of a problem was another one. This is both of these are publicly traded companies. I'll leave their names out. They came to me and said, hey, we want to monitor the weights, fill levels of bins moving in our warehouse as we build product. We want to sensor every tray, every tub, and know what's in there. And I said, great. What's the economic benefit of doing that? Well, I don't know. Well, how many of these trays do you have censored? Well, we have one sensor and it's on my kitchen table at my house. Okay. Maybe it's a good idea. I don't know. But there was no implied economic benefit. Okay, next use case. The second one that I think you have to weight equally with the impact is, do we have data? We would often read a description that sounded really good and had a huge economic benefit. And as we did due diligence on the data sets, they simply didn't have enough data to train the algorithm. The results would not have been helpful at all. And so one of the recommendations we have with these choices people make is, no matter what you're doing, okay, start collecting data. And I've gotten pushback on this approach. Like people say, well, what if we don't ever use it? And we've done all this work to like collect it. I still think you're better off collecting data because you never know when it might be useful. Data is the new currency, okay? AI is just the way you extract value out of it. So I think the data discovery part combined with the economic or the value statement has to be done. And that's how you make choices about where to start.
So can I ask a question there, Jim? Can I ask a question? So if I understand what you're saying correctly, so something we see is there is a real challenge in the quality of the data, right? And potentially the availability that you're talking about. So in your opinion, then when starting at the very beginning, it's just get as much as you possibly can, and then start to fine tune. Quality is not as big of a thing.
There are no perfect data sets. Okay, thinking that I would see companies do this early on, because at first they were like, we're not using the cloud. Okay, and then their next excuse was, our data are not perfect. The cool thing about AI is it can tolerate some dirtiness in the data. Because you're feeding it training labels of what good looks like. And you're doing that at a fairly large scale. So even if you have some anomalies in your data sets, those surface during discovery. They surface during the output. So, I do agree that garbage in, garbage out, but AI can actually tolerate some level of inequality or bad quality in data. It doesn't have to be perfect.
Fantastic. So where does one start from a technical standpoint? So we spoke a little bit about the different trends in AI and IoT in the industrial space. We spoke a little bit about where to start, how to think about structuring this. What are some of the technical challenges for somebody starting on this journey? What do they need to be aware of? Do they need a lot of resources on board inside to train themselves, or do they need to bring in experts? Because we all hear that at one point we had a lot of data scientists that were needed. Now we feel that maybe some of those data scientists are not needed because AI has replaced, or generative AI may have replaced some of that. So how does one navigate in terms of deciding how do I figure out the right technology stack? Because it's a couple of different players in the market providing different services, and not everything is generative AI. You have to figure out what the right way to go about doing this. What are some of your advice to our folks who are listening in today on that? Jim?
When this was before Gen AI exploded, okay, this was probably circa 2017, 2018, 19, somewhere in there. Machine learning was being talked about everywhere. You go to every conference and everybody's now an ML expert. Okay, now everybody's a Gen AI expert. You look at someone's LinkedIn and they've taken the latest class from Coursera and they're now a data scientist. Okay. I still believe today that the most important decision that somebody will make in this journey is the next person they hire. Hard stop. Like, you want somebody who knows what they're talking about. You want somebody who has done this before, and not somebody who's just like completed their first Coursera course, right? And now they're the expert. I do think it's good money spent to have at least one good data scientist available, whether that's a contractor or an employee, kind of doesn't matter. But in your first project, you want somebody to guide you. There are still lots of choices in the market, even though simplicity continues to, I think, drive the discussion. AWS and Azure and Snowflake continue to come out with Google with products that industrial companies can use, enterprises can use to help solve this problem on top of their architectures. Companies like Databricks and others are really investing in this. C3 AI continues to evolve, what they're doing. So I do think there are a lot of great tools and options, but I still think you need somebody who is grounded on these various approaches, because there is not a silver bullet and it is hard work. So that would be my first recommendation, is get somebody who knows what they're doing. The second one is there's going to be this conversation about, I like this tool or I like that tool. I came from this space. I built tools that I thought were the greatest thing since sliced bread. I sold them. People prefer different things. So, I would get too wrapped around the axle around tools. I would just start somewhere with something. You may evolve into something that works for your company, or your company may have standards. Like, we're an AWS shop. Okay, AWS has tools. But I do think if this is going to be a strategic pillar that's on the CEO's desk of the company, we are an AI first company. To me, that individual who's making that statement, whether they're a public company or not, should be investing most of their R&D into that. So I do think that, getting a staff of people that know what they're doing would be very helpful. It has gotten easier. Okay. In the past, you would aggregate data sets in some cloud repository. You would get a Python notebook and start writing Python code and start generating. This was all very manual. Pull this library and do it. It's very static. It's not versioned. Data sets are still a mess. Today, a lot of that has been, I would say, modernized in AI stacks, where you have orchestration layers, you have very visual drag and drop applications of machine learning libraries or whatever to apply on the data. And you can get very quick results with not a lot of work. But I still think you need a data scientist as you start and go down this path. So I'm okay if people disagree with me on this, by the way. I don't profess to be the world's foremost expert on where someone should start, but I do think having somebody who knows what they're doing is good advice.
Yeah, I think we see that a lot too. What we kind of recommend is, because of the diverse pieces of the solutions that the customer is trying to solve, is we really need a lot of overlap and have the right people. To your point, Jim, it's not just data scientists. There's certain IT people. There different professionals within the organization need to be able to work together to kind of stitch together what their end result is, and not just sort of hand it to one person. has maybe taken one class, to your point,
Yeah,
right?
exactly.
You need multiple stakeholders to make sure that the result is what the organization is trying to get to.
And it can get complex in IoT. Like we've worked on, if you go to Hackster, .io and go to the search bar and type in blues and let's say Edge Impulse, you'll find a bunch of projects on Hackster that developers have built that are AI applications on the edge. And so I think it's not just a where do I start, but if in the context of IoT, of devices connecting to the internet, or I just say the cloud, you know, you have to ask yourself the question, can I afford latency?
Right.
Right? If you can afford latency, you can process the stuff in the cloud at much larger scales than you can on the edge. If you can't afford latency, then you need to say, what is my hardware capable of doing on the edge? Because you can actually lay down AI or machine learning down onto the processor on an edge device, but it has to be trained. This isn't like magic. There's no magic here, okay? And if Edge Impulse is killing it right now. They've been a great partner to a lot of companies, including Blues, but they basically train these machine learning classifiers in the cloud and then lay it down onto the edge device and it runs. It may not be great forever. You may have to retrain it. So you bring the data sets back up, retrain it, and lay it back down. But that's you have to first start with business value. Do I have data? And then where is it going? Where in the stack is it going to occur? Is it going to occur on the edge, or is it going to occur in the cloud, or both?
Or some combination. Yeah, or some combination.
So, and these are really cool projects. Like one of the ones we did was a thermal image detection for leaks in hot water systems. And so the camera is sitting there running, kind of taking thermal imagery of these big, huge boilers to see if there's any leaks on it. But that all that processing was being done on the host MCU, and only the results were being sent to the cloud. So Blues was the communication component in the middle, and we're not pulling all of the data, all the thermal imagery data off the device. We're only pulling the results. And so your payloads back to the cloud, your economics of cloud costs are completely optimized for what you're doing because you're doing the processing right there.
So let's shift a little gears towards the analytics part. We know, in all of these industries, we're looking at alerts, detection, and those kind of things, right? Is AI helping with the analytics part in terms of either detecting anomalies or detecting certain trends and things like that? What are you seeing in terms of what folks are doing on that front? Is there a lot of prediction happening in terms of, hey, these things are going to go bad or these things are going to happen, and let's go and put a focused effort? How is that process of getting that's trained and getting some good predictions and then making actions out of that? How is that process happening with clients and projects from your experience, Scott?
So today, much to Jim's point he just made there, there's a kind of a cost benefit analysis going on. So today what we're seeing most customers do is they're doing a lot of sort of monitoring at the edge to figure out what the end result needs to be, and then that result is the only thing being sent today to kind of minimize cost. I think ideally the customers are telling us they would like much more processing to be done at the edge, to where the machine learning or the AI can actually do the next action. Right. Today there's a little bit of hesitancy today. I think a little bit of probably non-trust around the hype of AI, and that they still want a person involved in the decision-making tree. If it's a minor thing, they'll have the AI go ahead and make the decision. But the more costly or the more important that the event is, they want a person to pull the trigger. So I think for what we see is the next stage is actually giving the AI more autonomy, more authority to be able to say, okay, this is the action that needs to be taken. Go ahead and make the decision and do it, and then let someone know.
Jim, would you like to add anything to that?
Yeah, AI making decisions can be a little scary for people. If you think of operators who run equipment and they've been working with this equipment or various models of it throughout their career, they're very hesitant to let a computer make a decision for them in most cases, especially if it could have real operational impact. And so the advice I would give to people is it's not impossible to get people who are hesitant to do this over that hump. But there's some period of time when you're rolling these things out where if the model is predicting, hey, this valve is going to fail, or this part of your supply chain is going to bottleneck because you have a limitation over here and you need to change these settings. You need to allow the operator to see these recommendations and be involved in the decision process for some period of time. Let's say 3 months, 6 months, I don't know. Some period of time where they can gain confidence that, hey, every time that thing has told me to do this, it's done the same thing I would have done. And then you can start turning these things on. So I do think that there is a level of psychology that goes with rolling out AI in industrial contexts, especially if people are worried about safety or anything like that. You have to give them time to experience what life is like with this thing on. Second point is, I think we always need to step back and ask ourselves, what is today's human-computer interaction model that we as humans are familiar with? Okay, you asked about alerts. I think most humans today are familiar with alerts. We get them from our bank accounts. We get them from fraud detections on different things. We may work in environments in industrial contexts where all we deal with all day is alerts. So I do think still a very supported output of an interaction model between a computer and a human is an alert. How that alert got generated from a variety of data sets and some very complex, processing that may be being done on their behalf to come up with that may be very complex. But I do think a completely acceptable output is an alert with maybe some information about why that alert is happening. There is tuning that goes on. It will always go on with AI. Data sets change, environmental factors change, production factors change. And with that, you need to constantly be wary of, AI is not something that you just train it once, set it and forget it. You may have to retrain and reclassify at points as things in your operating environment change as well. So a lot of factors, it's like fine tuning a race car at every race, but I do think alerts are acceptable. And I do think that it's important to give experienced operators time to fall in love with this new tool that is at their hands.
Do we see some of these AI capabilities helping operators, or are we seeing this kind of take away or change the nature of jobs that some of these operators are having to do? What are you seeing in terms of that? Are we still far away from those kind of adoption, or still trying?
It's already happening. At every point of an industrial revolution, okay, and this is one, jobs changed. This is a fact, okay? Things are going to change. A job that existed 5 years ago could be on its way out right now. I just got back from Hannover Messe in Germany. It's a massive manufacturing show. There was a whole hall dedicated to robots. These were jobs that humans used to do. And there wasn't like 2 companies that had robots. There was like a whole hall of robots that did jobs that humans used to do. These robots are trained with AI. They have cameras on them. They are making decisions in real time. They don't get tired. They don't need insurance, So it's a fact, like jobs will change. I think the question that people need to be asking themselves is, what do I want my future to be as these things change? Like, we need to be constantly retooling ourselves. Some people want to do that and some people don't. So, I can't give a recommendation to somebody about what they should do in their career if they feel it's threatened by AI, but I can tell you it is happening. It's not.
Fantastic.
It's not going to stop.
We have a few more minutes left. If the audience has any questions, feel free to ask. I do have a quick question. While how is AI helping with some of these things that Keith was mentioning earlier? Security is a pretty hot topic, and everyone's talking about it. Are there some special approaches that is being taken, combining AI and cybersecurity in the industrial space?
I mean, we see a couple of things there. AI looking for anomaly detection, looking for kind of weird weird devices trying to connect to a network. Along those lines are kind of intrusion detection and prevention. Device authentication is probably the biggest one for us. Making sure that device is a trusted device. Using AI to actually manage the key to allow the device to access the network. Those are the other small ones are behavioral analysis, but that sort of device authentication, intrusion detection are the biggest that we see today.
I see. I got a question from the audience. With the incorporation of AI industrial operations, how quickly operators get adapted to the new environment?
This is one of those it depends questions. But in projects that I've worked on, I've seen this happen in months. Okay. It doesn't mean that there still won't be resistance. Human nature is something that is hard to change. But operators can get used to these functions in months of time because they see enough volume going through their life every day that if it's actively turned on and they're engaging with it, they can actually get to the point where they agree with it, or they can completely disagree, saying this thing is constantly wrong. That is also an acceptable response because you don't want to turn something on that is always wrong. So I think it's 3 months, 6 months, 9 months, type of time frame for most types of projects.
Fabulous. There's another question from the audience. Any advice on preventing theft from retailers with IoT and AI?
Yeah,
go ahead, Joe. Well, I was going to say, we do work on some projects where it's not retail specific, but there is some sort of behavioral analysis that goes on there of using AI to see if things are going in and out of certain locations at, call it, odd hours of the day. Right. So if it's if the location should be closed, but there are sensitive things happening inside those kind of off limit times, that can usually be construed as theft. That's kind of how we that's kind of an early piece of it. But using AI to kind of look for data breach, on those off hour pieces. Jim, you want to expand?
I'm assuming he's talking about like brick and mortar locations. Those type of retailers. Okay. Anything's possible. I've seen technologies that censor display racks where you stock goods, clothing racks, cameras, and located all over. I think these data sets have to be trained on what is bad behavior, and to the extent that things coming in and out of doorways can be monitored. I think you can find it. There are now cashierless stores. So I would probably look at their business models and what they're doing. There's probably some level of theft that they're tolerating, I would have to imagine. But they're assuming most people are probably going to pay. But yeah, I would look at some of those models. I'm sure it's been solved. I haven't worked on it personally.
One more question here. As a device manufacturer, what hooks can we embed into our devices to enable connectivity to these ecosystems as they evolve?
Into devices. There's a lot of ways to do this. It kind of comes down to, is your device wired or wireless is one question, because there are different hooks you would use in that situation. Are you worried that if your device loses power that you lose all visibility to it? Is another question. So there are hooks that you want to plan for when you're thinking about what you can tolerate and what you can't. For example, somebody who's got a bank of refrigeration and freezer cases in a grocery store doesn't want to lose connectivity to the sensors in those machines, even if the store loses power momentarily because of the temperature settings on the foods that are in them. Those are hooks you have to premeditate. You have to set those, all for the purpose of continuing to get data off of the machine. Again, back to the kind of the core principle that I talked about earlier. So yeah, there are a myriad of hooks. There are processors you can embed that allow you to do edge computing on your device. There are processors that don't do that. So yeah, there's a bunch of tools available that exist today that are very mature.
Thank you, Jim. I think we're almost at the hour here on our schedule. As a closing remark, would you like to, what is one or two things that you would like to share with the audience here as a takeaway from this session? Jim, each of you.
Yeah. First of all, thank you, everybody. I love this subject. I could go on and on about it, but just real quick, I think Gen AI changes everything. Okay. And I think there are two things people should be watching and educating themselves on, and you can experience today, even if you're not implementing it in your business. One is large language models. So think ChatGPT. I think most people are getting very familiar with what that is and its evolution. The second one, though, that I think has a huge impact on industrial contexts is large action models. Okay. You may not have heard this term before, but to me, this is the nirvana right now of AI in an industrial context. A large action model is basically a sequence of trained things where the computer is making decisions based on the processes that are involved in some context. This is already being done on the consumer side, but I think the next shift we're going to see is LAMs in industrial, and that will have an immediate impact on the IoT discussion. So to me, I think that's where this is all going. That would be my closing thought. Again, thank you, everybody.
Scott?
Yeah, thanks for having me too, everybody. I'm going to echo Jim's thing. Jim's statement is, basically now AI is here. I think 5 years ago we talked about it. It kind of reminds me a little bit of machine to machine or IoT, where it was always coming, but it took a very long time to actually get here. AI is now here, and so you need to be prepared. Talk to your suppliers, look for talent, and start to lay the bedrock of how to implement that AI in your business.
Fantastic. Thank you, everyone. This has been a wonderful session. We learned a lot from our panelists today on AI. I certainly learned about LAM. That's pretty interesting. I'm going to look into that. Thank you, everyone, for attending this session. And over to Keith.
Yeah, thanks to you, Renil. Thanks for moderating. Great job. And thanks to Jim and to Scott. Terrific stuff, guys. I took notes. I learned a lot. And a big special thanks, most of all, to our audience. Thanks so much for joining us. I remind everyone once again that we'll be holding open forums on IoT security for the month of May. We start a week from today, where Z Hossein will be hosting a session on network security, and we'll go from there. So please check out the IMC website to see about that. As we say about Z, he's forgotten more about IoT than most of us know. So really looking forward to that. And then later on, well, I guess we don't have that slide, do we? But later on in June, we'll be having another of our IoT Days events, and certainly hope everyone can join us for that. Please check us out on the IMC website. Thanks, everybody. Terrific session, and look forward to seeing you next time.
Bye, everyone.
Thanks.